What is the machine learning process? Now, the machine learning process involves building a predictive model that can be used to find a solution for a problem statement. Now, in order to solve any problem in machine learning, there are a couple of steps that you need to follow. All right, let's look at the steps. The first step is you define the objective of your problem, and the second step is data gathering, which is followed by preparing your data, data exploration, building a model, model evaluation, and finally making your predictions. Right. Now, in order to understand the machine learning process, let's assume that you've been given a problem that needs to be solved by using machine learning, right? So, the problem that you need to solve is you need to predict the occurrence of rain in your local area by using machine learning. All right? So basically, you need to predict the possibility of rain by studying the weather conditions. So, what we did here is we basically looked at step number one, which is define the objective of the problem. Now, here you need to answer questions such as what are we trying to predict? Is our output going to be a continuous variable or is it going to be a discrete variable? These are the kind of questions that you need to answer in the first stage, which is defining the objective of the problem. Right. So yeah, exactly. What are the target features? So here you need to understand which is your target variable and what are the different predictor variables that you need in order to predict this outcome, right? So here our target variable will be basically a variable that can tell us whether it's going to rain or not. Input data is we'll need data such as maybe the temperature on a particular day or the humidity level, the precipitation, and so on, right? So you need to define the objective at this stage. So basically, you have to form an idea of the problem at this stage, right? Another question that you need to ask yourself is, what kind of problem are you solving? Is this a binary classification problem, or is this a clustering problem, or is this a regression problem? Now, a lot of you might not be familiar with the terms classification, clustering, and regression in terms of machine learning. Don't worry, I'll explain all of these terms in the upcoming slides. All you need to understand at step one is you need to define how you're going to solve the problem. You need to understand what sort of data you need to solve the problem, how you're going to approach the problem, what are you trying to predict, what variables you'll need in order to predict the outcome, and so on. Right, let's move on and look at our step number two, which is data gathering. Now, in this stage, you must be asking questions such as what kind of data is needed to solve this problem, and is this data available? And if it is available, from where can I get this data and how can I get the data right? Data gathering is one of the most time-consuming steps in machine learning process. If you have to go manually and collect the data, it's going to take a lot of time. But lucky for us, there are a lot of resources online which provide data sets. All you have to do is web scraping, or you just have to go ahead and download data. One of the websites I can tell you all about is Kaggle. So if you're a beginner in machine learning, don't worry about data gathering and all of that. All you have to do is go to websites such as Kaggle and just download a data set. So, coming back to the problem that we are discussing, which is predicting the weather, the data needed for weather forecasting includes measures like humidity level, the temperature, the pressure, the locality. Whether or not you live in a hill station, such data has to be collected and stored for analysis, right? So all the data is collected during the data gathering stage. This step is followed by data preparation, or also known as data cleaning. Right? So if you're going around collecting data, it's almost never in the right format. And even if you are taking data from online resources, from any website, even then the data will require cleaning and preparation. All right? The data is never in the right format. You have to do some sort of preparation and some sort of cleaning in order to make the data ready for analysis. So what you'll encounter while cleaning data is you'll encounter a lot of inconsistencies in the dataset. Like you'll encounter some missing values, redundant variables, duplicate values, and all of that. So removing such inconsistencies is very important because they might lead to any wrongful computations and predictions. Okay, so at this stage, you can scan the dataset for any inconsistencies and you can fix them then and there. Now let me give you a small fact about data cleaning. So there was a survey that was done last year or so, I'm not sure. And a lot of data scientists were asked which step was the most difficult or the most annoying and time-consuming of all, and 80% of the data scientists said it was data cleaning. Right. Data cleaning takes up 80% of their time, so it's not very easy to get rid of missing values and corrupted data. And even if you get rid of missing values, sometimes your dataset might get affected, right? It might get biased because maybe one variable has too many missing values, and this will affect your outcome, so you'll have to fix such issues. You'll have to deal with all of this missing data and corrupted data, right? So data cleaning is actually one of the hardest steps in machine learning process. Okay, now let's move on and look at our next step, which is exploratory data analysis. So here what you do is you basically become a detective in this stage. So this stage, which is EDA or exploratory data analysis, is like the brainstorming stage of machine learning. Data exploration involves understanding the patterns and the trends in your data. All right? So at this stage, all the useful insights are drawn and any correlations between the various variables are understood. What do I mean by trends and patterns and correlations? Now let's consider our example, which is we have to predict the rainfall on a particular day, so we know that there is a strong possibility of rain if the temperature has fallen low, right? So we know that our output will depend on variables such as temperature, humidity, and so on. Now, to what level it depends on these variables? We'll have to find out that, right? We'll have to find out the patterns and we'll have to find out the correlations between such variables. So such patterns and trends have to be understood and mapped at this stage. Alright, so this is what exploratory data analysis is about. It's the most important part of machine learning. This is where you'll understand what exactly your data is and how you can form the solution to your problem. Alright. The next step in a machine learning process is building a machine learning model, so all the insights and the patterns that you derive during the data exploration are used to build the machine learning model. So this stage always begins by splitting the data set into two parts, which is training data and testing data. I already discussed with you that the data that you use in a machine learning process is always split into two parts. Right? We have the training data and we have the testing data. Now, when you're building a model, you always use the training data, so you always make use of the training data in order to build the model. Now, a lot of you might be asking, what is training data like? Is it different from the input data that you're feeding to the machine, or is it different from the testing data? Now, training data is the same input data that you're feeding to the machine. The only difference is that you're splitting the data set into two, right? You're randomly picking 80% of your data and you're assigning it for training purpose, and the rest, 20%, probably you'll assign it for testing purpose. Alright, so guys, always remember another thing, that the training data is always much more than your testing data, right? Obviously, because you need to train your machine, and the more data you feed the machine during the training phase, the better it will be during the testing phase. Alright? Obviously, it'll predict better outcomes if it has been trained on more data, correct? So the model is basically using the machine learning algorithm that predicts the output by using the data fed to it. Now, in the case of predicting rainfall, the output will be a categorical variable, right? Because we'll be predicting whether it's going to rain or not. Okay? So let's say we have an output variable called rain, right? The two possible values that this variable can take is yes, it's going to rain, and no, it won't rain. Correct? So that is our outcome. Our outcome is a classification or a categorical variable. So for such cases where your outcome is a categorical variable, you'll be using classification algorithms. An example of a classification algorithm is logistic regression. Or you can also use support vector machines, you can use k-nearest neighbor, and you can also use naive bias and so on. Now, don't worry about these terms. I'll be discussing all these algorithms with you, but just remember that while you're building a machine learning model, you'll make use of the training data. You'll train the model by using the training data and the machine learning algorithm. Now, like I said, choosing the machine learning algorithm depends on the problem statement that you're trying to solve. Because there are n number of machine learning algorithms, you'll have to choose the algorithm that is the most suitable for your problem statement. So step number 6 is model evaluation and optimization. Now, after you've done building a model by using the training data set, it is finally time to put the model to a test, right? The testing data set is used to check the efficiency of the model and how accurately it can predict the outcome. So once the accuracy is calculated, any further improvements in the model can be implemented. During this stage, there are various methods that can help you improve the performance of the model. Like you can use parameter tuning and cross-validation methods in order to improve the performance of the model. Now, the main things you need to remember during model evaluation and optimization is that model evaluation is nothing but you're testing how well your model can predict the outcome, right? So at this stage, you will be using the testing data set. In the previous stage, which was building a model, you'll be using the training data set, but in the model evaluation stage, you'll be using the testing data set. Now, once you've tested your model, you need to calculate the accuracy, right? You need to calculate how accurately your model is predicting the outcome. After that, if you find that you need to improve your model in some way or the other because the accuracy is not very good, then you'll use methods such as parameter tuning, right? Don't worry about these terms. I'll discuss all of this with you, but I'm just trying to make sure that you're understanding the concept behind each of the phases in machine learning. It's very important you understand each step. Okay, now let's move on and look at the last stage of machine learning, which is predictions. Now, once the model is evaluated and once you've improved it, it is finally used to make predictions. The final output can either be a categorical variable or a continuous variable. Now, all of this depends on your problem statement, right? Don't get confused about continuous variables, categorical variables. I'll be discussing all of this. Now, in our case, because you are predicting the occurrence of rainfall, the output will be categorical variable. Right? It's obvious because we are predicting whether it's going to rain or not there itself. We understand that this is a classification problem because we have a categorical variable. So that was the entire machine learning process.